Hi everyone, in this video we are going to discuss about vector addition in 2D plane. So when you have two vectors or three vectors which are collinear in the sense they can be arranged in a single line, maybe parallel or anti-parallel. So if you have two vectors or three vectors, adding or subtracting vectors is easy. We have seen it already in the previous video. If you want you can check it up again. So in this video, if you have two vectors in a plane, like say for example xy plane, you have it, and in which a vector can have infinite possible directions from 0 degrees to 360 degrees. Okay. Likewise, if you have two vectors or three vectors, how do we find the resultant of those two vectors? That's going to be what we are going to discuss today. So for that, actually, there is a law of vector addition. So first of all, whenever you come across a law in science, you please remember that it is a conclusion based out of experimental observations, exhaustive and consistent experimental observations under certain conditions. So law has an experimental basis, not a theoretical basis. So you observe them in daily life, it seems to be following certain trend. So that's what is law when we talk about in science. So law of vector addition is what we are going to discuss today in plane. To understand law of vector addition, I'll take one example. Okay, so usually displacement is a very good example for vector, and if you study in terms of displacement, I think you will feel that which is going to be much more intuitive and easy to visualize. For that reason, let us take an example of displacements. Let's consider two vectors. Maybe I'll take them as displacement vectors. A bar is one vector and B bar is another vector. Okay, but note, this law of vector addition is valid even if they are not displacement vectors. For any vector it is valid, but I'm taking displacement vectors for the visualization purpose, better visualization purpose. Okay, two vectors are there. I'll give a description just to get a feel of it. Imagine that this is a holiday and you are at home and your home is at origin. The coordinates of your home or the address code or a pin code of your home is 0, 0, and you have your friend over here, friend's home, located at x coordinate 15 units and y coordinate 5 units. So this is the home of your friend, 15 meters or 15 kilometers, 5 kilometers, that you decide the units there. And you both want to go to movie theater, let's say, which is located over here, for example. So this is a movie theater location whose address codes are x coordinate is 20 and y coordinate is 15. 20 comma 15 is the coordinates of the movie theater. So you started from your home, went to your friend's home, collected him, and then you both went to movie theater. Let's take that a particular example. So when you are going like that, first you started from your home and went to your friend's home. When you're going like that, it doesn't mean that you should go in a straight line path, unless otherwise you take a helicopter where you can go in straight line path. On the road there will be a lot of obstacles. Roads are always bending, curvy and all that. So you might have taken some complicated path to go from your home to your friend's home. But when you are talking about displacement, we don't care about the path for a given set of initial point and final point. It is the shortest line directed from initial position to final position. That is going to be the displacement. Okay, so A bar is the first displacement you had as you move from your home to your friend home. Then after that you took a second displacement from your friend's home to movie theater. Probably the path could be some complicated. We are not bothered about path when we discuss about displacement. So you reached movie theater and you are about to enter into your movie theater to watch your movie or whatever. And then suddenly, let's say you got a phone call from your siblings, maybe your brother or sister, just to find out where you are. Hey bro, where are you? You got a call and you say that I'm in a so and so movie theater. Where is it located? And you give the coordinates of it. So address basically. You say 20 comma 15. The moment you say that, your brother or your sister can easily visualize, okay, so you started from home, you went somewhere in between the intermediate stage, they don't care. Finally, where you are, that's final, ultimate resultant displacement. And that is going to be the shortest directed path from initial position to the final position. That is your resultant displacement. That's how we calculate the resultant displacement. So now we come back to this vector. You see this particular diagram, it is forming a triangle. This is called triangle of vector addition. So we say that A bar and B bar are component vectors and S bar is the resultant vector. A bar plus B bar equal to S bar. That's the equation, we write it. It is completely different from the real number additions. It's a geometrical addition we are looking at. And this law, as I told you, is valid for all kinds of vectors. And for that matter, it is seen that this law is a defining law for a vector. A vector is the one which obeys this law. A vector is the one which obeys this law. If a quantity is there, some physical quantity, it might have a magnitude and direction. If it doesn't follow this law of addition, then we say that it is not a vector quantity. There are some examples in physics, like electric current seems to be having direction and magnitude at a particular point, but it does not obey law of vector addition. Same way speed of light or velocity of light, wave velocity basically. Even though at one particular point they seem to be having direction, but they don't follow the law of vector addition. That's why we call them as scalar quantities. Okay, come back here. So now when you move, maybe you can have a look at the length of it. What is the resultant vector? 25 units resultant, and it is making an angle 36.9 degrees with positive x-axis. It has got components. Components we'll discuss about it in the next video. So in this, if I vary one vector, okay, I think I moved the wrong vector. So if I vary one vector, you see that the resultant will change. Okay, if magnitude is changed or the direction is changed, automatically resultant is going to change. So if vectors are collinear, parallel, okay, parallel meaning collinear, even anti-parallel also collinear, okay. In this case, you will see that it is going to be straight line. I'm not able to get exactly parallel. Yeah, I got it now. Anti-parallel now. A bar and B bar are anti-parallel. A bar and B bar parallel. So then we can use that one-dimensional addition. Whenever they make different angles, you form a triangle. So the third side of the triangle would represent the displacement, resultant displacement, or resultant of those two vectors. Of course, when you are adding two vectors, right, they are supposed to be of same physical quantities. You can't add a displacement vector to velocity vector. It is like adding a mango to monkey. So two mangoes and three monkeys will be equal to how much? There's no meaning to it. So they should be of same physical nature when you are adding two physical quantities. The resultant also will be of the same nature. So this is one interesting way to look at it. So the third vector, third side is a resultant vector which forms completes the triangle there. The why named triangle of vector addition? Because it is forming the triangle. So sometimes you might have more vectors. Instead of two vectors, you might have three vectors probably. Let's say you have another vector. Say for example, I take this vector C bar. Okay, maybe after completing your watching your movie, probably you had gone to some other location. You went to maybe a football stadium probably to watch football or a soccer ball, depending on where you are located. So finally, let's say you are here. Now if you got a call and then they ask you to find the resultant displacement from initial position to final position, that is going to be the resultant displacement. So you can have any number of vectors whose addition or resultant you want to calculate. The first step is to arrange them in an order. When I say arrange them in order, what I mean is that tail head order. So the head of the first vector should touch the tail of the second vector, and then head of the second vector should touch the tail of the second vector, and so on. You keep arranging them like that, any number of vectors. So then the resultant would be directed from tail of the first vector to head of the last vector. That's going to be the resultant. In that process, it is going to create one polygon. any diagram in 2D plane having more than 3 sides is called polygon. So that's why it is called polygon law of vector addition. When you have two vectors to add, you say that it is triangle of vector addition. Whenever you have more than two vectors, the same idea, but the diagram would be polygon. So we call it as polygon law of vector addition. So with that, I conclude here. Thank you very much. Goodbye.